you ever wondered how submarines can travel deep beneath the ocean and then return to the surface with ease? Today, we're diving into the fascinating world of submarines to uncover the secrets behind how they go up and down in the water. Submarines are remarkable vessels designed to operate underwater for extended periods. Their unique ability to control their depth is what sets them apart from other ships. In this video, we'll explore the science and technology that allow submarines to dive deep and surface safely. Let's begin our journey by understanding the basic structure of a submarine and why depth control is so crucial for their missions. Submarines must be able to move up and down in the water for a variety of reasons. Whether it's to avoid detection, navigate underwater obstacles, or reach specific depths for research, depth control is essential. Unlike surface ships that float on top of the water, submarines need to adjust their position vertically. This ability is what makes them so versatile and effective, especially in military and scientific application. Understanding how submarines manage this feat helps us appreciate the complex engineering involved. Next, let's look at the main components that make depth control possible. The heart of a submarine's ability to dive and surface are its ballast tanks. These are special compartments located within the submarine's hull. By controlling the amount of water and air in these tanks, submarines can change their overall density, allowing them to sink or rise as needed. When a submarine wants to dive, it fills its ballast tanks with water, making it heavier. To surface, it pumps the water out and fills the tanks with air, making it lighter. This simple yet ingenious system is the key to a submarine's vertical movement. Let's take a closer look at how ballast tanks operate. When the submarine needs to dive, valves open to let seawater flow into the ballast tanks. This increases the vessel's weight and causes it to sink. To rise, compressed air is blown into the tanks, forcing the water out. As the tanks fill with air, the submarine becomes lighter and starts to ascend. This process is carefully controlled by the crew to ensure smooth and safe movement. The balance between water and air in the tanks is what allows precise control over the submarine's depth. Science behind a submarine's movement is based on the principle of buoyancy. Buoyancy is the force that allows objects to float or sink in a fluid like water. When the submarine's weight is greater than the water it displaces, it sinks. When it's lighter, it rises. By adjusting the amount of water in the ballast tanks, the crew can control the submarine's buoyancy and therefore its depth. This principle is not only crucial for submarines but also for many other vessels and objects that travel through water. Achieving neutral buoyancy is a key goal for submarines. This means the submarine's weight is exactly equal to the weight of the water it displaces, allowing it to remain at a constant depth without sinking or rising. The crew carefully adjusts the ballast tanks to maintain this balance. Neutral buoyancy is especially important during underwater operations, as it allows the submarine to stay steady and conserve energy. Mastering this delicate balance is a testament to the skill of the crew and the sophistication of submarine design. When a submarine needs to dive deeper, the crew allows more water into the ballast tanks, increasing the vessel's weight. This causes the submarine to sink further into the ocean. The process is gradual and controlled, ensuring the submarine descends safely. The deeper the submarine goes, the greater the water pressure it must withstand. Submarines are built with strong hulls to handle these extreme conditions. The ability to dive deep is essential for military missions, scientific research, and exploration. Return to the surface, the submarine's crew uses compressed air to force water out of the ballast tanks. As the tanks fill with air, the submarine becomes lighter and begins to rise. This process must be managed carefully to avoid surfacing too quickly, which could be dangerous. The crew monitors the submarine's ascent, making adjustments as needed to ensure a smooth and safe return to the surface. Surfacing is just as important as diving, and both require precise control and coordination. In addition to ballast tanks, submarines are equipped with trim tanks. These tanks help adjust the submarine's balance from front to back or bow to stern. By moving water between trim tanks, the crew can control the angle of the submarine, making it level or allowing it to tilt as needed. This fine-tuning is crucial for maneuvering and maintaining stability, especially during complex underwater operations. Trim tanks work alongside ballast tanks to give the crew full control over the submarine's position in the water. Submarines also use hydroplanes, which are like underwater wings, to help control their movement. These control surfaces can be angled to direct the submarine up or down as it moves forward. By adjusting the hydroplanes, the crew can make the submarine ascend or descend smoothly, even while traveling horizontally. This adds another layer of control, making it possible to navigate complex underwater environments with precision. Hydroplanes work together with ballast and trim tanks for complete depth management. As submarines dive deeper, they encounter increasing water pressure. The deeper they go, the greater the force pressing against the hull. Submarines are built with strong reinforced structures to withstand these pressures. Understanding and managing pressure is critical for safe operation. The crew monitors depth and hull integrity constantly, ensuring the submarine remains safe at all times. This ability to handle extreme pressure is what allows submarines to explore the depths of the ocean. Heart of submarine operations is the control room. Here, the crew monitors all systems, including ballast and trim tanks, hydroplanes, and pressure gauges. Advanced technology and teamwork are essential for managing the submarine's depth and position. The control room is filled with instruments and displays that provide real-time information, allowing the crew to make quick and accurate decisions. This environment is a testament to human ingenuity and the power of modern engineering. Operating a submarine requires a highly trained crew working together seamlessly. Each member has a specific role, from monitoring systems to adjusting controls and communicating with other departments. Teamwork is vital, especially when diving or surfacing. The crew's expertise ensures that every movement is precise and safe. Their dedication and skill are what make submarine missions possible, whether for defense, research, or exploration. Safety is a top priority on any submarine. Multiple systems are in place to prevent accidents, including emergency ballast blow systems that can quickly bring the submarine to the surface if needed. Regular drills and checks ensure that the crew is always prepared for any situation. These safety protocols are essential for protecting both the crew and the vessel during underwater operations. The combination of technology and training keeps everyone safe below the waves. Submarines are used for a variety of missions, from military patrols to scientific research and underwater exploration. Their ability to control depth allows them to operate in environments that are inaccessible to other vessels. Whether tracking marine life, mapping the ocean floor, or conducting covert operations, submarines rely on their depth control systems to succeed. Each mission demonstrates the versatility and power of these incredible machines. Diving to great depths presents unique challenges. The pressure increases dramatically, and the risk of equipment failure grows. Submarines must be meticulously maintained and operated to handle these conditions. Advanced materials and engineering techniques are used to build hulls that can withstand the crushing forces of the deep ocean. The crew must also be prepared to respond quickly to any issues that arise during deep diving. Staying in touch with the surface is vital for submarine operations. Special communication systems are used to send and receive messages while submerged. These systems must work reliably even at great depths, where radio waves don't travel well. Submarines use sonar and other technologies to maintain contact and navigate safely. Effective communication is another reason why teamwork and advanced technology are so important on board. Submarines need powerful energy sources to operate their systems, including those for depth control. Many modern submarines use nuclear reactors, which provide the energy needed for long missions underwater. Others use batteries or diesel engines. The choice of power source affects how long a submarine can stay submerged and how deep it can go. Efficient energy management is crucial for safe and successful operation. Living on a submarine is a unique experience. Space is limited, and the crew must work and live together in close quarters. Every member plays a vital role in keeping the submarine running smoothly, including managing depth control systems. Life underwater requires discipline, teamwork, and adaptability. Despite the challenges, many submariners find their work rewarding and exciting, knowing they are part of a remarkable team. Marine technology has evolved dramatically over the years. Modern submarines feature advanced materials, improved ballast systems, and sophisticated control mechanisms. Innovations in design have made submarines safer, more efficient, and capable of diving deeper than ever before. Engineers continue to push the boundaries, developing new ways to enhance depth control and overall performance. These advancements ensure submarines remain at the cutting edge of underwater exploration. Operating submarines responsibly is important for protecting the ocean environment. Modern submarines are designed to minimize their impact, using quieter engines and environmentally friendly materials. Research missions often focus on studying marine life and ecosystems, helping scientists understand and preserve the underwater world. Responsible operation ensures that submarines can continue to explore the ocean without causing harm. Throughout history, submarines have played key roles in exploration and defense. From military operations during wartime to groundbreaking scientific discoveries, submarines have proven their value time and again. Famous missions include exploring the Titanic wreck, mapping the ocean floor, and conducting covert surveillance. Each mission showcases the importance of depth control and the incredible capabilities of these vessels. Becoming a submariner requires extensive training. Crew members must learn how to operate complex systems, respond to emergencies, and work as a team. Training includes simulations of diving and surfacing, as well as drills for handling unexpected situations. This preparation ensures that every crew member is ready to manage the challenges of life underwater and maintain the submarine's depth control system. Navigating underwater is a complex task. Submarines use sonar, maps, and advanced navigation systems to find their way. Accurate navigation is essential for safe diving and surfacing, as well as for completing missions. The crew must constantly monitor their position and adjust course as needed. Navigation systems are integrated with depth control to ensure the submarine stays on track. Submarines are invaluable tools for scientific research. They allow scientists to study marine life, geology, and underwater ecosystems up close. Depth control systems enable submarines to reach specific layers of the ocean where unique discoveries can be made. Research conducted from submarines has expanded our understanding of the ocean and its inhabitants, leading to new insights and innovation. The future of submarines looks bright, with ongoing advancements in materials, energy, and control systems. Engineers are developing new ways to make submarines more efficient, quieter, and capable of diving even deeper. Autonomous submarines and remotely operated vehicles are expanding the possibilities for underwater exploration. As technology evolves, submarines will continue to play a vital role in science, defense, and discovery. There are many myths about submarines, from how deep they can go to what life's like on board. In reality, submarines are highly advanced machines operated by skilled crews. Their ability to dive and surface is based on scientific principles and precise engineering. Understanding the facts helps us appreciate the true capabilities of these vessels and the people who operate them. Submarines have captured the imagination of people around the world. From movies and books to documentaries, these vessels are often featured in stories of adventure and discovery. Their mysterious ability to disappear beneath the waves and reappear at will makes them fascinating subjects. Popular culture has helped bring the world of submarines to a wider audience, inspiring curiosity and wonder. Summary: submarines go up and down by carefully managing their ballast and trim tanks, using hydroplanes, and relying on the principles of buoyancy and pressure. The combination of advanced technology, skilled crews, and precise engineering makes it possible for submarines to explore the depths of the ocean safely and effectively. Their ability to control depth is what makes them such powerful and versatile vessels. As we look to the future, submarines will continue to evolve and push the boundaries of what's possible underwater. With ongoing advancements in technology and engineering, these incredible vessels will play an even greater role in exploration, science, and defense. The art of going up and down in a submarine is a perfect blend of science, teamwork, and innovation, opening new frontiers beneath the waves.